So we left off here at number 2 with a whole bunch of stuff to talk about variance and standard deviation. Now remember, we know how to calculate it, not too bad, but more important than knowing how to calculate is knowing how to interpret it. Because on your tests and stuff, a lot of times I'll give you the statistics, you just have to figure out what's going on. So if the computer program or the computer output I give you just shows you one or the other, how do you find the other? That was not good English. If it shows you standard deviation, how do you find variance? Well, you square it. So if you've got standard deviation, you square it to find the variance. So if I gave you in a computer output that the standard deviation is 4, you square it, 4 times 4 makes 16 to find the variance. By the same token, if I give you variance but not standard deviation, you take the square root to find the standard deviation, right? So if the standard deviation is 5 because the variance was equal to 25. Square root of 25 is 5. All right, number 3, important point, is that variance and standard deviation are not resistant to outliers. Why? Well, because the variance and the standard deviation were both found by finding the deviation from the mean. And remember from section 3.1, we learned that the mean is not resistant. So if the mean doesn't resist outliers, then how could the variance and standard deviation resist outliers? They couldn't. Right? There's no way that the variance and standard deviation can be resistant because they're built from the mean and the mean is not resistant. But why is that important to us? Well, it's important because if your data set is skewed, that means that the variance and the standard deviation are not good, right? And we're going to learn an alternative to them in section 3.4 to make up for this, right? But if your data set is skewed, then variance and standard deviation are kind of skewed too. All right. What does the standard deviation mean? And there's a typo here. It should say stats exam scores. So it's your give or take from the mean. That's what standard deviation is. It is literally the average plus and minus from the mean, right? How much above and below the mean should you expect to be? So for our stats exam, for example, if we were in that class that took that stats exam, we'd expect to have a score of 74%, because that's what the mean was, give or take 13.97, right? It's the give or take. You can also say plus or minus, give or take, plus or minus from the mean. That's how to interpret it. That's what it is. It's how much wiggle room there is around the mean for most people, for most data points. All right. Next, standard deviation for Wendy's and McDonald's. So remember, we had that Wendy's and McDonald's way back. There it is, Wendy's and McDonald's. We saw Wendy's had smaller spread, right? So I want to interpret that. I found them right there. I used a computer program. The mean was 1.39. The variance, the standard deviation was 0.738 for Wendy's. So what does that mean if you go to Wendy's? So the average wait time at Wendy's for lunch, I should say, for lunch, and it's at that Wendy's, not all Wendy's, but for lunch was 1.39 minutes, give or take 0.738 minutes. Notice, by the way, that the minutes and minutes thing, and I put it up here, the percent and percent thing. Standard deviation should have the same units. So I put it right here. Standard deviation has the same units as the data. Okay, so if your data is in minutes, then so is the standard deviation, well, as is the mean as well. If your data is percent, then so is the standard deviation. All right, done with that one. Next, what about if I just give you a computer printout? Can you read it? That's the kind of thing that's going to show up on your final exam, right? Okay, so what is the range for this data set? What is the variance? What is the standard deviation? And I gave you 3 different computer programs. This one is Excel. Excel does this kind of thing if you have an add-in for Excel. Don't worry about it if you don't have it. I've shown you how to find it. And then StatCrunch right here. It should look familiar. And then there's a more important program called Minitab, which is really a big deal in statistics courses as a general rule, but it costs money, so I didn't bother having you guys do it. Also, as you can see, it's kind of harder to work with. All right, so we're going to find all these, and I'm actually going to do it with highlighters. I'll be right back. I'm going to make little boxes around everything, so hold on. There we go. I've got them all colored now. Okay, so the range is 156. You can see it right here in the Excel output. There it says range right there in StatCrunch, and Minitab is right down here. And again, there's no guarantee on the order. You just got to kind of search around because it's a long story. But I mean, as you saw with StatCrunch, I could kind of click things off and click things on, and that would affect the order. So don't expect them to always be in the same place. Variance is right there in blue, 1458, 1458, 1458. They don't always show the same decimal places, so just keep that in mind. Are you going to have all three to look at? No. What's going to happen on the final is I'll pick one. You know, honestly, it's probably going to be StatCrunch or Minitab most likely, but I sometimes do Excel. Just depends on the topic. So you'll have to kind of look at one of them and figure things out. But for the notes, I show you all three. Okay, so do those computer outputs, are they giving us sigma squared or s squared? And the answer to that is a big ol' s squared, right? Okay, s squared. Why? Well, because we almost never need sigma squared, because we almost never have all the data for the whole population. Okay? I mean, most of the time you're going to be working with a sample, like a lot of the time. Now, not always. It's going to, in probability chapters, we work with sigma, but in non-probability chapters, we generally work with S because you don't get the whole data set. If you had the whole data set, you wouldn't have to go out and do anything. All right? I mean, we would know what everything is. So I have everybody. So why are you going to go research them? No reason, you know. So if you know what everybody is, then you don't need to do research. Okay. So what does this mean for the US, this lovely mean and data set that we have here? So we have this data set about the US exports in billions of dollars. So we expect the US to export 29.64, oops, I better put a dollar sign in there, $billion to any given country, give or take 38.19 billion. Now I know you're thinking, notice that, ooh, the 38.19, that give or take is larger than the actual average. So what's that going to mean? It's going to mean that you can actually export, if your give and take includes negative amounts. That's kind of a clue that this was, and if you remember from section 3.1, this was a skewed right distribution. Remember how the mean is 29.6, the median's 18.3? See, now you're seeing what's happening. Because it's skewed, it's pulling the mean, and it's affecting that standard deviation and that variance. Remember we said that variance and standard deviation are not resistant right here. We said it back a page ago. They are not resistant to outliers. If the data is skewed, they're not really that great, which they're not in this case. So you're ending up with a value that's lower than the average actually was for the country. But that's okay. We'll live. That's all we wanted to do at this point, was to interpret it. Okay, on to the next problem. I'm not entirely certain why this got off center here, but I'll fix that in a second. At least I'm trying to. My computer's not liking me very much right this second. It never likes graphs from Minitab, which is what those are. Okay, there we go. I had to zoom out a little bit so you could see them. All right, so what I've got is I've got a whole bunch of standard deviations here, and I've got the 6 graphs that go with those. And these are all bell-shaped and lovely graphs. So your mission is to match the standard deviation number value with the graph that it must be. And I've already done this one right here. This one's 0.5. Now you can tell it's 0.5 because it's the most packed. It has the smallest standard deviation. So let's see, what else would be easy? The other one that should be easy is the one that's the largest, right? So that would be the 3 value, which is, hold on, I copy. Ugh. There we go. Bear with me, I'm having to fight my computer quite a bit right this second. So, all right, so the one with the most spread, that I know I copied and pasted a whole bunch of 3's in here, but bear with me, they're not all 3. So the one that is 3 is this one right here in the bottom left corner. Do you see how he's the most squished, the most spread out? That's 3, right? 3 would be the most spread out, it's the largest. All right, now what about this one up here? This one in the top right corner, that's got to be 0.75 because it's tightly packed, but it's not as tightly packed as this one over here with the 0.5, right? But it's more tightly packed than the 3 that are remaining. All right, so that's the 0.75 one. All right, now what about this one right here? This one's kind of flat, kind of mushed. So that's got to be the 2, right? Because remember, standard deviation means that it's how spread out it is. This one's way more spread out than this one right here at the 0.75. That leaves the 2 hardest ones in the bottom right corner. So this one and this one, right? So which one of these is more spread out? Because whichever one's more spread out, that's the one that's 1.25. And whichever one's less spread out, more tightly packed around that center. You can't see my hands, but I'm making like a squishy motion with your hands. So if you're more packed in around the center like this one is, then you're going to have the smaller number. So that one's got to be 1, and this one's got to be 1.25. Again, the more tightly packed it is, the smaller the number. The more spread out it is, the larger the number. Oops. And that's what we're going to write right here. So let me type that up. Hold on. There we go. Larger the standard deviation, the more spread out the data are. And the smaller the standard deviation, the more tightly packed the data are. Okay. If we are comparing 2 or more populations, the one with the blank standard deviation is the one that, well, I guess I could say larger standard deviation is the one that is more widely dispersed, i.e. more spread out. Cool. Done with that. All right, we are done with standard deviation and variance. I hope you enjoyed them. We will move on to the empirical rule next time. See you then.